Hey everyone, welcome back to my channel Physics with Sebbi. Let's have a look at the amazing question taken from SHM. A small ball of mass small m is attached to the inner surface of a thin hoop of mass capital M. The radius of the hoop is smaller. Hoop can roll along the horizontal surface without slipping. Acceleration due to gravity is g. Find the period of oscillation of the hoop around the equilibrium position for smaller amplitudes. Before going to check out my solution in detailed way, explore your great thoughts to crack at it. Now you watch the solution. In this problem, our target is to figure it out the time period of the system. I came here to explore the solution with animation for better understanding. For this hoop and ball system, we have to find out the time period. Here you see this system. This is the hoop of mass capital M and this is the small ball of mass small m attached to this hoop. The line joining the center of mass and this ball makes an angle alpha with this vertical line. This hoop is translating with the velocity Vc and rotating with omega, and its rolling is pure rolling without slipping. To find out the time period of this system, first we have to calculate the kinetic energy of this ball, the kinetic energy of the hoop, and potential energy of this ball as well as the potential energy of this hoop. To find out the kinetic energy of this ball, first we have to find out the velocity of the ball with respect to the ground. Here, with respect to the center of mass, its rotation is pure rotation about this center of mass. Therefore, the velocity of the ball is along the tangential direction with respect to the center of mass, that is VBC. To the ground, its velocity is VBC plus VC, means velocity of the ball with respect to the ground can be written as velocity of the ball with respect to the center of mass plus velocity of the center of mass. Velocity of the ball with respect to the center of mass can be written as r omega, because about the center of mass its rotation is pure rotation, therefore it can be written as r omega. And velocity of the center of mass is also equal to r omega, because at this point of contact there is no slipping, means the translational velocity of the hoop towards right and there is no slipping, therefore Vc is equal to r omega. That's why Vbc is equal to r omega is equal to Vc. For this ball, we can apply parallelogram law. Here this angle is alpha, therefore the angle between these two velocity vectors is also 180 minus alpha. By using parallelogram law, we can find out 2Vc sin alpha by 2. Therefore, total kinetic energy of the system is equal to the kinetic energy of this hoop due to translation, that is half mvc square. The kinetic energy of the hoop due to the rotation, that is half I omega square, as well as the kinetic energy of this ball, that is half mvg square. Vc is nothing but omega square r square, right? And I, the moment of inertia of the hoop, that is mr square, right? And Vg square, which is nothing but 2Vc sin alpha by 2. That also we have to keep here. And simplify this, we will get like this. Take mr square omega square as common, then we will get this term. Here, for smaller amplitudes, alpha is very small, therefore sin square alpha by 2 is neglected. Finally, we get Vk is equal to mr square omega square for this system. Omega can be written as alpha dot square. The potential energy of the system we can find out with respect to this reference line. With respect to this reference line, the potential energy of the hoop is 0 because its center of mass lies on the reference line, and the potential energy of this ball is can be written as minus mg r cos alpha, because with respect to this reference line it is at the depth of r cos alpha. Therefore, potential energy of the ball can be written as minus mg r cos alpha. Now the total energy, potential energy plus kinetic energy of the system is constant because there is no loss. Therefore, the total energy of the system with respect to the time is not changing. Therefore, its derivative is 0 with respect to the time. By simplifying this, we will get the second order differential equation in terms of alpha dot, alpha double dot and alpha, and m, g and r. From here, this term is nothing but omega square, right? So we can write omega square is equal to mg by 2mr. From there, omega is equal to under root of mg by 2mr. From there, we can write the time period of the system can be written as 2 pi by omega. Just you plug in omega value in this, you will get 2 pi under root of 2m by m r by g. Have you enjoyed this video? Subscribe for future updates. Please like and share my video. Have a nice day.